There we go. Okay, so as we were saying a couple seconds ago, um, so this is the stuff that's going to be on the quiz from section 5.3. All right, I want to go over 5.1 and 5.2 because it's been a minute since we've done 5.1 at least. Okay, so I want to hit those two, and we got like 17 minutes left, so we should have time. So what number did I give you? 225? Is that what I said? Oops. Gotta click off of this. All right, there we go. All right, so if I went there, and I went up, right? Always take it. So I told you what is the cosine and sine of, or I asked you what the sine of, cosine and sine of 225 is, right? So this would be at 225. Everybody understand why? If this was 45 degrees, we went over 180. 180 plus 220 or plus 45 is 225. All right. So I asked you what the sine and cosine is, or cosine and sine. So this one would be the cosine, and this one would be the what? Would be the sine. These are numbers I told you to memorize. Okay. Do you remember how far over on a 45, 45, 90 triangle? How far over? Again, the hypotenuse is 1, right? It's a unit circle. So if you went over, how far? Square root of what? 2 over 2. That's a number you have to remember. I told you many times, go back and look at the videos on several occasions, right? I said, memorize these numbers. These are numbers that you need to know, right? So you got to know them, and you got to know them tomorrow, all right? So, but you went to the left, because remember, this is going to be negative, negative, isn't it? So what's the cosine? So if I asked you what the cosine of 225 degrees is, what would you tell me? You got to go over to the you got to go negative. So it's negative what? No, it's not 2 over 2. It's square root of 2. It's a huge difference. Well, it's not what you said. So it's the square root of 2 over 2. All right, what's the sine of 225 degrees? It's also negative square root of 2 over 2, isn't it? Everybody see that? All right, so it's negative square root of 2 over 2. What if you wanted to find the tangent of 225 degrees? What would you do? What's the tangent? Something over something. Yeah, it's opposite over adjacent, but as far as cosine and sine is concerned, sine over cosine, all right? It is opposite over adjacent because look, there's opposite, there's adjacent, but what's the opposite side? It's the sine. Okay, so remember it in terms of that, all right? So the tangent is the sine over the cosine. So what is the sine? Negative square root of 2 over 2. Over the cosine, it's just a 1. Exactly right. Can you do that? Yeah, if you can do that, you can do that question on the quiz. We good? What's a cotangent of 225? Still 1, isn't it? Because the cotangent is just the inverse of the tangent, right? The inverse of 1 is just 1, right? So the cotangent, tangent, in this case, they're exactly the same. It's not always going to be that way, but in this case it is. We got it? Let's do another one. I don't even put any 30 or 60 in here, so I stick with the 45s. And you only have like 2 problems like this. Let's get rid of all this mess.
You found the cosecant. You flip the square root of 2 over 2.
Yeah, okay, good question. So what if I said, what is the cosecant of 225? 225. You would just do what? Take the sine. In this case, the sine and cosine are the same anyway, so it doesn't really matter which one you use. But technically, you should use the sine because the cosecant and the sine are inverse of each other, okay? So what would I do? I would go negative 2 over the square root of 2. But you don't leave it like this, do you? Yeah, you got to... Yep, square root of 2 over square root of 2. And that gives you, still is negative. So what do we got? Negative 2 square root of 2 on the top, and it's on the bottom. Square root of 2 times square root of 2 is just 2. One more thing. Cancel those out. So what's the cosecant of 225? Negative square root of 2. That's really not a number that I've memorized, but I can always find it. All right, if I know what the sine is, I just flip it, and that's what the cosecant is. If I know the cosine, I just flip it, and that's what the secant is. Got it? Not all these things you could probably do in your head, but some of them you should. For instance, a quadrantal angle. What does that mean? Where does it lie? A quadrantal angle. Give me the first 4 quadrantal angles. Starting at 0, 90, 180, 270. Okay, everybody got that? So let's pick one. Give me one. 270? Okay. So here's 270. So what is, first of all, let's do the ordered pair first. Remember, it's a unit circle, okay? So what's the ordered pair at 270 degrees? 0, -1. Good. So if I asked you what the cosine of 270 was, without a calculator, okay, you should be able to do this. What is the cosine of 270? It's 0. Exactly right. See how easy it is? And then what's the sine? It's -1. You got it. Equals -1. What's the tangent of 270? It's the sine over the cosine, right? Or the y over the x. Okay, I wouldn't think opposite over adjacent because you don't really have a triangle here, do you? All right, so I wouldn't use that. Okay, I would just say the sine over the cosine. What is the sine over the cosine? Well, that's -1 over 0. What's -1 over 0? It's undefined, okay? That means the empty set. Did I ever tell you that? That circle with it just means empty set, which means it's undefined, okay? What if I asked you for the cotangent of 270? That's right. It would be 0 over -1. Now, 0 over -1 is something. What is it? It's 0. So the cotangent of 270 is 0. Getting the hang of it? Yeah. So I give you, basically, I only give you like 2 problems like that. All right.
Or just the
Well, it could be any of those. Okay. I give you one where it's some kind of form of 45 degrees. Then I give you one that's one form of the quadrantal angles. Okay. It could be at 0, 90, 180, 270. 10 questions. Yep. We good? We good? Okay. Let's do one more kind of like this. What should I do? Let's go back to this. Let me just grab this right there. Okie doke. All right, there's that. Let me, I don't know, I'll just make up a number. What if I give you the number -5, -5, 12? I gave you that ordered pair, okay? The question is going to be, this is number 10. I'll tell you right now. It's number 10 on the quiz. Find the values of the 6 trig functions for angle theta in standard position if a point with the given coordinates lies on its terminal side. That's very, very wordy. But what does that mean? That means I give you -5, 12. So what am I going to do? What's the first thing I'm going to do? I'm going to plot it, right? So -5 this way, 12 this way. It doesn't have to be exact. Okay, as long as you know how far over and how far up you went, and then I connect, and this is what I get right here. Everybody good? All right, so what am I going to do? I'm going to make a right triangle out of it. Where do I take it to? Do I take it over here like this? Nope, I always drop it down to the x-axis. Always, always. Okay? What's the length of this side right here? Well, we went to the left, so it's -5. What's this one? That's 12. Okay, the question says, find the angle in standard position. Standard position would be this angle right there. Okay, from the 0. So that's what I'm trying to find. I'm trying to find that angle. But I'm not going to find that angle directly. Which angle do you think I'm going to find? Well, I'm not really finding the angle. Okay, what I'm doing is just finding the trig functions associated with that angle. So really, I'm not finding the angle. I'm just finding the trig functions. Okay? So let's take a look at this angle right here, theta. Well, I have opposite over adjacent. What am I missing? Missing the hypotenuse, aren't I? Okay. I picked these numbers not just randomly. 5, 12, 13 triangle. That's right. Okay, so here's 5, here's 12. What's this? 13. What if I did not give you one of those special Pythagorean triple triangles? Yeah, you do Pythagorean theorem, and you'd find that. You might get some ugly number. It could be. It could come out real nice and pretty like this one is, okay, or it could come out kind of ugly. I'll give you a big hint. It comes out nice and pretty, okay, on the quiz. So you don't have to worry about doing the Pythagorean theorem, okay? Makes life a lot easier. So what am I trying to do? I'm trying to find sine, cosine, and tangent, and then the cosecant, secant, cotangent, all right? But once I get the first three, the other three are super easy. All I do is just, boom, flip it. Got it? All right? I like to go cosine first. They go sine all the time. It doesn't make any difference, does it? All right? So, again, I don't care what the angle is. I'm not trying to find the angle. We will later on, not much later, but a little bit later on, we will find exactly what that angle is. But that's not what we're going to do right now. All we're going to do is just find the cosine, sine, and tangent of that angle. All right? So there's the cosine, there's the sine, there's the tangent. Almost wrote cotangent. All right, let's do the cosine. What's the cosine? Now, this is not a unit circle this time, is it? All right, because that thing's 13. So we got to do the opposite hypotenuse adjacent thing. All right, so the cosine of that angle is what? It's adjacent over hypotenuse. Anybody playing along? All right, you guys remember anything? All right, almost knocked him out, man. He almost fell out of his seat. You all right, Gideon? I don't want you getting hurt. All right, here we go. So if you'd write this down, if you'd be writing this stuff down, it might make you stay awake a little bit. I don't see too many people writing this down. All right, so here we go. What's the cosine of this? It's adjacent over hypotenuse. So it's what? It's negative 5, over 13. It's that easy. That's it. Well, for the cosine, I can do 6 of them, but that was the first one. What's the sine? The sine is the opposite over the hypotenuse. So what's that? It's 12 over 13. Then the tangent is the opposite over the adjacent. So it's negative 12 over 5. See how easy that is? All right. How did I get that triangle? I just went to the left, went to the right, dropped this straight down. Okay, I've got my angle inside of here. You always take the angle to the x-axis. Okay, you don't use this angle up top here. Always use the angle that goes to the x-axis. Got it? Okay. Now the rest should be easy. So what's the secant of the angle?
13 over 8.
Well, it's negative, right? 13. Doesn't matter where we put the negative. Doesn't make any difference. Could be on the top, bottom, in the middle. Doesn't make any difference. What's the cosecant of the angle? 13 over 12. And what is the cotangent? Yeah, now you're getting the idea. So negative 5 over 12. And that's it. That's number 10. Different numbers, but it's the same idea. That's easy, isn't it? Yeah. All right, let's go to that first stuff. We haven't done this in a little bit. So I'm going to ask you, let's just do the example in the book. Let's see which one I'm doing. This one. We're going to change it from degrees and decimals into degrees, minutes, and seconds. Remember doing that? All right, it's been a while. I'm going to use the one in the book. This is probably the one that we used in when I taught the lesson, so it should be in there. So right now, I'm sorry, this is degrees. That's degrees, okay? So it's 15.735 degrees. Does that mean it's like 7 minutes, 35 seconds? No. It just means it's that much of a degree. It's almost, right, 16 degrees, but not quite. So what do we got so far? Well, I got 15 degrees. So what do I have to do? I got to take this, change it into minutes, and change it into seconds. So what I'm going to do is go 0.735. Okay, it's not over 60 because it's this much of 1 degree. Of means multiply. Okay, so we take this and we multiply it by what? 60. Okay? And then we get a number, 44.1. So it's this. It's 15 plus this stuff. All right, so we got 15 plus, and then you multiply that together, you get 44.1. Yeah, that's in minutes. This is in degrees, that's in minutes. Now, we don't want the 0.1 degrees, do we? We want to take that 0.1 and do what to it?
60.
Again, multiply it by 60. Because this is 0.1 minutes, right? There's 60 seconds in a minute, so we multiply it by 60. And what's that, just 6? Yeah. And then what's our answer? It's 15 degrees, 44 minutes, and 6 seconds. Make sense? All right.
Was there something else?
We're going to do it another way. Yep, we're going to do another one. So this is a decimal of a degree. The bell might ring, but can we hang out just for a minute or two? All right, so this one, they give it to you in degrees, minutes, and seconds. There's degree, there's minute, and there's seconds. And what we have to do is change that into degrees point something. All right, so it's just all degrees. All right, it's going to be a decimal of degrees, but it's going to be 39 point something degrees. All right, so the 39 I'm good with. I can just keep that the way it is. What am I going to do that at 5 minutes? Now, this time, instead of multiplying by 60, what are we going to do? We're going to divide by 60. And then we're going to take that 34 and we're going to divide it by 3,600, right? Because it's 60 times 60, okay? Everybody see that? All right, and then you just add those up. All right, so it's going to be 39. You can do the math on your own. I'm just looking in the book. It's 0.093, and that's in degrees.
So you divide 5 over 60, divide 34.
Yeah, to go to this, right, the minutes you divide by 60, the seconds you divide by 3,600. Then add them together, right. If I take this fraction and this fraction, add them together, this is what I'll get. Okay? Yeah. There's one more. What if I said, this is again from the example, what if I said you had 3.3 rotations?
360 times.
Okay. Yeah, where am I at? What angle am I at? It's very simple. It's just 3.3 what? Times 360. You got it. And then whatever that comes out to be, 1980. And yep, 1980. I was in 10th grade. I was almost your age, 1980. Well, actually, I was your age. All right, there you go. Everybody good? Okay, you're welcome.